of course, if we can do an indefinite integral with partial fraction decomposition, then obviously we can do a definite integral with partial fraction decomposition. So first step, we'll notice that the degree of the numerator, now if you look there, there isn't anything there, which really means it's a 1, and that's degree 0, right, because there's no variable in it. The degree of the denominator, there we go, is 2, because it's a squared, right? That's your highest degree term. Obviously, degree 0 is less than 2, so yay, we're good. All right, so there's step 1. Step 2, we will rewrite our lovely integral. I'm just going to put 1 in the numerator. I think that's easier to understand. And I will factor the denominator into the sum and difference of two conjugate terms, where one is a plus and one is a minus, right? Because this was the difference of squares. All right, so that's step 2. Step 3, I will break it up into two fractions with unknown coefficients. So it'll be a over t plus 3 plus b over t minus 3, or if you like minus 3 plus 3, it doesn't make any difference, just as long as you have each of them there. All right, so there's step 3. Step 4, I need to make the equation. So I need to, don't worry about the integral parts, just worry about the, actually, as a matter of fact, I don't really quite know why I'm doing that. I don't really need the integrals. I'm not working with integration right now. I'm only working with the fraction part, the integrand. So I'm going to get rid of all of that. There we go. All right, so then this is, you multiply everything by that common denominator of t minus 3, t plus 3. And that gets you 1 equals a times t minus 3, because the t plus 3 will cancel on that one, plus b, and then there the t minus 3's cancel, and you're left with t plus 3. All right, so there's step 4. Now step 5, I mean, this one rather obviously falls into the camp of let's substitute some values. So if we choose t equals 3, this will disappear. I'll be left with 1 equals b times 6. So b is 1/6. And then similarly, if I choose t equals negative 3, then this term will exist. So it'll be 1 equals a times negative 6 plus 0, right? Because the second term will disappear. So that means that a is negative 1/6. All right, so there's step 5 right here. I found my coefficients. Step 6, now I'll bring back the integral. Now I'll rewrite it. So 0 to 1 of 1 over t minus 3 t plus 3, or if you like, you could write the original integral, it doesn't make any difference, is equal to the integral from 0 to 1 of, okay, a was negative 1/6 over t plus 3 minus, oh no, plus positive 1/6, right? Because b is positive 1/6 over t minus 3. There's the minus dt. Well, luckily neither of these needs u substitution or anything like it. So this would be negative 1/6 natural log absolute value of t plus 3 plus 1/6 natural log absolute value of t minus 3. And all of that is from 0 to 1. Okay, so now it's just a question of putting in those values. So when I put in 1, I'll be negative 1/6 natural log of 4 plus 1/6 natural log of absolute value of negative 2. So there's 1 going in, minus negative 1/6 natural log absolute value 0 plus 3 is 3, plus 1/6 natural log absolute value 0 minus 3. Okay, now the absolute value of negative 3 is 3. So this is minus a 6 natural log of 3 plus a 6 natural log of 3. These two end up canceling each other out. They're the same value. So that just leads me to this numbers in front. So this is, let me factor 1/6 out of this. And I'm actually going to reverse the order. So this is the natural log of 2 minus the natural log of 4. And I don't need the absolute value anymore because I turned this positive, right? I mean, if you want to see what's happening here, you're welcome to. It's negative 1/6 natural log of 3 plus 1/6 natural log of 3, right? And they're gone. So that whole thing is 0. All right, so this is the answer. So it's 1/6 natural log of 2 minus the natural log of 4. And of course, we can use our lovely powers and powers and quotient property of logarithms and make this the natural log of 2 divided by 4, which would be the natural log of a half, which would be the natural log of 1/2 to the 1/6 power. Or if you like, the natural log of the 6th root of 1/2, like that. Any of those would also work. Not required necessarily, but always fun to use our logarithm properties.